the most advanced passenger jet ever built, is being sent to the desert to die. Not because it crashed, not because it failed, because it worked exactly as designed, and the world moved on anyway. The Airbus A380 is enormous in a way that stops making sense if you look at it too long. The passenger cabin spans 2 full decks, running the entire length of the fuselage. Laid flat, the usable floor space covers roughly the same footprint as 3 full basketball courts stacked end to end. It can carry over 550 people in a standard configuration. Some operators fit more than 800 inside. It is, by almost every measure, a triumph of engineering. And airlines are parking them permanently. To understand why, you have to go back to the problem the A380 was actually built to solve. Because it was not built to be big for the sake of being big. It was built to fix a specific crisis that was quietly strangling the world's busiest airports. By the late 1990s, major airports were running out of a resource that has nothing to do with money. They were running out of slots. A slot is a window of time when an aircraft is permitted to land or depart. At London Heathrow, Frankfurt, and Tokyo Haneda, those windows were almost completely full. You could not add more flights. The sky above the airport was not the constraint. The ground was. Airlines reached a logical conclusion. If you cannot run more flights, run bigger ones. Pack more people onto every movement and extract more revenue from each slot. The math was clean. The solution seemed obvious. And Airbus decided to build it. What emerged was genuinely staggering. The upper deck on the A380 is not a small premium section squeezed above the cockpit the way a Boeing 747 is configured. On the A380, the upper deck runs almost the full length of the plane. 2 complete floors of passengers from nose to tail. The wingspan stretches to 261 feet. That is wider than the Wright brothers' entire first flight was long. The tail fin rises to nearly 79 feet off the ground, roughly the height of an 8-story building sitting on a runway. Emirates, Singapore Airlines, and Qantas bet heavily on it. Terminals were rebuilt at Heathrow, Dubai, and Singapore Changi to handle the aircraft's size and dual-deck boarding. Airbus invested over $25 billion in development and production. The global hub-and-spoke model of long-haul aviation quietly reorganized itself around the assumption that the A380 was the future. Then the cracks appeared, and they were not in the airframe. Here is where common sense breaks down. When most people imagine a larger plane, they picture a cheaper ticket. More passengers means the fixed costs of the flight get divided more ways. Simple division. The A380 should, in theory, be the most cost-efficient passenger aircraft ever flown. In practice, it became one of the most expensive to operate per seat the moment it was not completely full. The aircraft only becomes economical at very high load factors, meaning the percentage of seats actually filled with paying passengers drop below roughly 85%, and the economics start collapsing fast. The plane burns through roughly 11 gallons of fuel per mile, regardless of whether those extra seats are occupied. 4 massive Rolls-Royce Trent 900 engines, each one roughly the diameter of a wide-body fuselage, consuming fuel at a rate that does not respond to how many people are sitting behind the wing. To put that appetite into scale, a fully loaded A380 flying from New York JFK to London Heathrow burns enough jet fuel to fill roughly 2,000 bathtubs. Every single flight, whether every seat is taken or whether 300 of them are empty, those 4 engines consume at nearly the same rate. The fixed cost of pushing that airframe through 6 miles of atmosphere does not adjust for demand. That fuel burn alone is not a death sentence. The deeper problem is what happens once the plane lands. When an A380 pulls into a gate at Dubai International or Singapore Changi, it is not just parking an airplane, it is docking a small city. Ground crews must simultaneously service 2 separate decks, coordinate multiple jet bridges positioned at different heights on the fuselage, manage catering for over 500 passengers across both floors, refuel an aircraft carrying up to 84,000 gallons of fuel capacity, run full safety checks, and complete the entire turnaround fast enough to protect the departure schedule. That process takes longer, consistently longer. Every extra minute an aircraft spends at a gate is a minute it generates no revenue. A Boeing 787 Dreamliner carrying 290 passengers can be turned around and pushed back in roughly 45 minutes at a well-run hub. An A380 at the same hub, moving more than double the passengers across 2 floors, rarely matches that window. The complexity of the operation scales faster than the capacity does. You do not just need more of everything. You need more of everything coordinated simultaneously across 2 levels of a fuselage, the length of a city block. So you now have an aircraft that needs to be nearly full to make financial sense, takes longer to fill, takes longer to empty, and requires gate infrastructure that most airports never built. Outside a small group of purpose-equipped mega hubs, the A380 was an expensive and complicated guest at nearly every airport on its network. Any one of those problems might have been manageable in isolation. Airlines adapt. Infrastructure gets funded. None of it was necessarily fatal on its own. The killing blow came from an engine. In 2009, Boeing began delivering the 787 Dreamliner to its launch customers. In 2013, Airbus followed with the first A350 XWB deliveries. Both aircraft were built around a new generation of high-bypass turbofan engines that represented a genuine step change in fuel efficiency. Not a refinement of the previous standard, a step change. The difference is easier to feel with a direct number. Flying a full A380 from Los Angeles to Sydney burns roughly 63,000 gallons of fuel. A Boeing 787, flying a comparable long-haul route, burns roughly half that. At $3 per gallon for jet fuel, the A380 crossing costs approximately $189,000 in fuel alone. The 787 equivalent costs roughly $94,000. Run that gap across a fleet operating 365 days a year, and it becomes a number that no pricing adjustment can close. The 4-engine configuration that gave the A380 its raw power also made it structurally expensive to keep in service during an era when twin-engine jets had grown capable of flying any route on Earth. 4 engines means 4 independent maintenance cycles, 4 complete overhaul schedules, 4 separate inventories of replacement components. Each Rolls-Royce Trent 900 engine weighs roughly 16,000 pounds on its own. That is approximately the same weight as a fully loaded concrete mixer truck, hanging under each wing. Keeping 4 of them airworthy simultaneously is a fundamentally different financial commitment than keeping 2. For decades, that commitment was considered worth making. Before the new engine generation arrived, regulations governing how far a twin-engine commercial jet could legally fly from the nearest diversion airport were strict enough to make transoceanic routes genuinely risky with only 2 engines. 4 engines provided the redundancy the rules demanded. The A380 made complete sense in that world. That world stopped existing before most of the A380 fleet had even been delivered. New generation high-bypass turbofan engines proved so reliable and produced so much thrust so efficiently that aviation regulators progressively extended the distances twin-engine jets were permitted to fly from a diversion airport. Routes that once legally required 4 engines could now be flown safely by 2. The Pacific, the North Atlantic, the Indian Ocean corridors. Every major transoceanic route opened up to twin-engine jets with sufficient range to cross them without a fuel stop. That single shift quietly dismantled the entire strategic foundation the A380 had been built upon. Airlines that had redesigned their networks around hub and spoke mega flights discovered that passengers actually wanted something different. Point-to-point routing, fewer connections, a direct flight from a mid-sized city on one side of the world to a mid-sized city on the other, without funneling through Frankfurt or Los Angeles or Dubai in between. A traveler flying from Austin to Tokyo does not want a connection through London if a direct service exists. a passenger flying from Perth to Dallas would rather land once. The 787 and the A350 made those connections commercially viable for the first time. A 290-seat aircraft could be filled profitably on a route that would never come close to filling 550 seats. More planes, flying more routes, serving more city pairs directly. That turned out to be what the market actually wanted. Not fewer, bigger flights. More, smaller ones. The A380 was the definitive answer to a question the industry had quietly stopped asking. Airbus formally ended A380 production in 2021. The last aircraft came off the Toulouse assembly line after only 251 had ever been built. The Boeing 737 family has logged over 10,000 deliveries. The 787 has surpassed 1,000. For a program that consumed over $25 billion in development costs, 251 aircraft is one of the most expensive commercial misjudgments in aviation history. The planes already in service will keep flying. Emirates operates over 115 of them and has committed to running its A380 fleet well into the next decade. On the right route, with seats close to full, the aircraft is still a serious machine. Dubai to London, Singapore to Sydney. A handful of corridors where passenger volumes genuinely justify the scale. But those corridors are narrower than Airbus ever projected. And they are not expanding. The largest passenger jet ever built turned out to be the last of its kind, rather than the beginning of a new category. Not because of a flaw in the composite wing. Not because the fly-by-wire systems failed. Not because a runway disaster shook public confidence. Because the logic that justified its existence had a shorter lifespan than the machines themselves. The slot crisis it was built to solve got bypassed by a different answer entirely. Smaller planes, more routes, better engines. The sharpest irony in the whole story is this. The A380 was designed to overcome a capacity problem at the world's most congested airports. The industry solved that problem by simply needing those airports far less than anyone expected. The routes the A380 could never efficiently serve, the thinner long-haul corridors that could not support 550 seats, are precisely the routes the 787 opened for the first time in commercial aviation history. Cities that had no direct connection to the other side of the world suddenly had one. The engineering behind that involves materials that did not exist in commercial aviation 2 decades ago, and a wing that flexes in flight in ways most passengers would find deeply unsettling if they watched it carefully from a window seat at cruising altitude. That story is worth understanding